Mr. Sam's we're in a new unit. Bonding. Hey, that's like 007, isn't it?
Yes.
Yes. Hey, you're like 007. How can you talk about
Bond?
James.
Chemical Bond.
Chemical Bond. Yeah.
It's his little brother.
Oh,
Not quite as famous.
No, I wondered. Yeah. So you got Chemical Bond. Yeah, there you go. Hey, didn't he play in a movie? His older brother James in a movie called Octopussy.
I think so.
Yeah.
Octo. And then there's a villain in Spider-Man named Doc Ock.
Doc Ock. He had like 8 somethings. Right?
He had his 4 regular appendages and then 8 mechanical appendages.
Oh, there you go.
Yep.
So hey, we're going to talk about the octet rule today. Yeah, so I bet that'll be interesting to learn about.
Yeah.
Hey, it's about bonding, so we should talk about. There's actually
different types of bonds.
Different types of bonds. There's 3 types of bonds. The first one's called ionic. Now, an ionic bond, it's a bond between a metal and a non-metal. All right. Now, if you remember back in the periodic table, right? Woo! Like my periodic table, Mr. Sam?
That's fantabulous.
And you've got the stair steps. Hey, Mr. Sam's, where's the metals?
Metals are to the left of the staircase.
Yeah, the metals are here, and then the non-metals are here.
Yep.
So it's basically the types of atoms that connect to each other.
Okay, so if you have a metal and a non-metal, you have an ionic bond.
Yeah.
Okay.
How about a covalent bond?
That's 2 non-metals bonded together.
So it's a non-metal to a non-metal. Okay. And metallic?
Those are just a bunch of metals.
Just a metal, just like a piece of iron or something like that. And we'll learn about each of these types in a subsequent podcast.
So my question then is, an atom doesn't really know that it's a metal or know that it's a non-metal.
Well, that's
obviously.
true. No, it probably doesn't.
How do they know, if you will, or what kind of bond to form with another atom?
Well, I think we have a video clip that would help us with that.
I think we might.
So how do atoms actually view each other? It's like, how do I view you as a person?
Amazingly, I'm sure.
Definitely, definitely. Yeah, amazingly. So why don't we watch this little clip?
All right, I'm standing here without a shirt on, and you're probably wondering what on earth is Mr. Sam's doing without a shirt on? Please put a shirt back on.
Oh!
Okay. Everyone always tells you that it's what's on the inside that counts, that matters. Well, you know what? In terms of atoms and bonding, that is complete and utter garbage. All atoms are very superficial. All they care about is what is on the outside of a neighboring atom. So, I'm Mr. Sam's. What's on the inside doesn't change much. However, if I have different things on the outside, you're going to perceive me differently and you're going to interact with me differently based on what is on the outside. So if you're walking down the street and you bump into me and I'm wrapped up in a blanket and I'm sitting on a corner, you are probably going to interact with me differently than if you saw me, say, walking down the street in a t-shirt that says Chalk Star to Rock Star. You're probably going to then treat me differently if I was wearing a lab coat. If you see someone in a lab coat, you probably think that they're on official business of some sort. So, even though I didn't change on the inside, the way I have things on the outside, the way I appear on the outside, you're going to interact with me differently, and that's exactly what happens in terms of atoms. They see another atom, and based on the outside electrons, that will determine on how they're going to bond with that other atom.
Well, I do view you now differently than I did a little bit ago.
Oh, yeah?
That was the first picture was scary.
Yeah.
No shirt on. Oh my
Yes,
gosh.
not a pretty sight.
It was not a pretty sight.
This skin doesn't see much sun.
Yeah.
As you can tell.
Okay. Hey, so we're talking about these things called valence electrons.
Yeah.
Those electrons are the electrons on the outer shell.
Right.
Like the clothing that you wear on the outside. So
Right.
people look at you differently with your lab coat than if you're
wrapped up in a blanket.
Wrapped up in a blanket,
Right.
like a homeless guy or
Right,
whatever.
exactly.
Right? So they are the outer shell electrons. So if we look at an atom over here on this picture, the nucleus would be down here with a positive charge. And there would actually be electrons here and here and here,
Right.
etc.
The thing is we don't care about those because they're not on the outer side. It's the outermost electrons, the valence electrons, that we're concerned about.
Yeah, and so it's the electrons, these electrons, these outer shell valence electrons that makes bonds happen. You might have an analogy. I just thought of one. If you're a high school kid, how do you judge if you're going to go out with a young man or a young lady? Probably by external appearances.
Yeah, generally speaking, that's kind of the first thing that most people look at.
So if you're a guy, if she's really pretty, then you're interested. And if she's not, maybe, then you're not. So it's kind of like the same thing. They bond, think the bond. They bond based upon outer appearances.
Okay.
I don't think that's always the best idea.
No, very superficial.
But that is, atoms are superficial.
Atoms are superficial.
So you can
just
see the
like
analogy.
Students.
Just like many students.
And many adults, for that
well,
matter.
Actually, sadly, that's true.
Yeah.
Okay. Hey, that leads us to something called the octet octet rule.
Octet. So we were talking about all the octo things at the beginning of this lesson, and octo just means
8.
8. Like if you sing in an octet, there's going to be 8 people in your group.
Do they actually have octets?
Sure.
Wow.
Okay, if you play piano or a musical instrument, and an octave has 8 notes.
That's true. Yeah. Okay. Okay. So atoms want to have the same electron configuration. Remember back to the unit on atomic theory
1s2,
as
2s2,
a noble gas.
Yep.
Now it turns out that almost all noble gases, except one, all of them except one, have 8 valence electrons.
What's the exception?
Helium.
Helium, right. Because helium only wants 2.
So neon, for example, his outer electron configuration is 2p2,
Nope.
2p6.
2s2.
2s2, 2p6. That's what I meant to say.
I know.
2s2, and if you add those up, that adds up to 8. So that adds up to 8. And so it's to have the same electron configuration. The one exception is helium, and he's just 1s2. He only has 2 electrons. Sometimes they call this the octet/duet rule.
Duet. 2 people.
For 2. Yeah, but they want to have the same electron configuration. You see, because noble gases, like see here, this picture over here, we've got 8 valence electrons. It's stable. It's the most stable thing, and so they're seeking stability.
So everybody wants 8. All atoms want 8. Now they don't want it like I want a cheeseburger, but that's the most chemically stable configuration. So that's why they want it.
Yes, the word "want" does make sense.
Right.
All right, leads us to a way that we symbolize things. Something called the Lewis dot structures. The dots indicate the number of. Actually, this says electrons. We should write valence electrons, outer shell electrons in the outer shell. Let's take a look. I want you to go to this slide here. I want you to take your periodic table out, and I want you to
pause.
Pause.
Take your periodic table out. We're not joking.
Yeah. Go. Yeah, and you're just going to write a number in front of on top of each column. 1, 2, 3, and then up to 8 here. These middle ones you can't really do this with because they're kind of schizophrenic and we can never figure them out. So
they're strange.
They're strange.
Yeah.
So, but we can do these other ones. So once you've done that, we're going to do some examples. Okay, so let's do some examples. Let's say I've got calcium.
Calcium is in column.
Let's go look.
Number 2.
Hey, calcium is right here. That number 2 means he's got 2 valence electrons.
Okay.
And to do those 2 valence electrons, you know what you do? You put 2
dots.
Dots.
And they should go in pairs.
They like to go in pairs.
Yeah.
Yeah. Let's do nitrogen. So I'm going to go find nitrogen. Nitrogen is over here, element number 7. But I don't care about the 7. I care about the valence electrons.
Okay.
The 5. You see, actually, there's 7. 2 of them we don't care about.
Because they're on the inside.
Because they're the inside electrons. They're actually called core electrons.
Everything or kernel electrons are sometimes called.
I've never heard that before.
Yeah.
So nitrogen gets 5. So you just put 5 dots around it. Bingo.
Okay.
Done. That's not very hard, is it?
No.
Or what's another couple we should do? Just
selenium.
Carbon and selenium. Let's do carbon and selenium. Actually, tell you what, guys. I want you guys to take carbon and selenium and do it on your own.
Pause.
Okay, carbon. Hopefully you paused.
Yes.
Here's carbon. He gets
4 valence electrons.
Actually, oftentimes the carbon, you might do them.
Yeah,
like
the
this.
poles, north, east, west, south.
Yeah, it doesn't matter.
Nah.
And then selenium here, he is in column numbers, 16 technically.
But it has 6
But he has 6 valence electrons, and so you'll do 6. Probably it's going to be 2, 4, 6.
Okay.
Isn't that easy?
That's easy. Is that it?
We have one more thing.
Okay.
So how do they achieve
8?
8.
So they all want 8. How do they get there?
Yeah, so how does an atom get 8? The answer is it varies. There's actually, we're going to not talk about one type of bond here, but in an ionic bond, remember that's got a bond between a metal and a non-metal. What they do is the atoms give and take electrons.
Okay, so an electron is transferred from one of those atoms completely to the other atom.
Yeah, and that's our next podcast.
Okay.
So I think we'll talk more about that in details. But just,
right.
The key thing is this word give and take, or I think a better word might be there's a transfer of valence electrons.
Alrighty.
And then for a covalent bond, instead of transferring the electrons, they share.
They share.
And we'll talk again. There's a whole podcast on each of these topics, and we'll get there as you watch these podcasts.
Okay.
And I think
that's it.
That's it. So we will see you in class, or if not, we see you on the internet. Goodbye.